What's something that sports cars, speedboats, and spacesuits have in common? Their complex forms, high strength, and lightweight construction are all made possible because of innovative products developed by Owens Corning. In this episode of Inside the Blueprint, we're going to learn about this company's revolutionary achievement, Rhino Mat, an innovative and next-generation material that is 6 times faster to install and has twice the strength of conventional high-density polyethylene. Rhino Mat is a reinforced composite geomembrane that is widely being selected by civil engineers for water containment applications. But what exactly is a geomembrane, and what makes it so special?
A geomembrane is actually a geosynthetic. Now, this is a man-made material that works in earth applications, civil infrastructure, in transportation, water resources, waste containment. We're actually using these man-made materials to enhance conventional construction practices.
Rhino Mat is a reinforced geomembrane that's puncture and tear resistant and plays an important part in lining protective facilities for environmental containment applications.
So a geomembrane is actually an impervious membrane. It's actually used to prevent the flow of liquids. And usually we're taking the liquids in a containment facility and keeping those from seeping into the groundwater. And that's to store the water for beneficial purposes or to keep polluted water from entering into the groundwater.
Now that we know why Owens Corning's reinforced composite geomembranes are so good, let's go see where and how it's made.
The Rhino Lab is the world's most advanced testing and prototyping center for geomembranes and roofing membranes and the likes. Included in the Rhino Lab is a 1/15th scale version of all of our production facilities. We have a team of 17 scientists and engineers that work every day to develop new inventions, product enhancements, new offerings to the market to fill unmet needs.
Rhino Mat is what we call a reinforced composite geomembrane. It's the next generation of geomembranes. It's lightweight, it's flexible, it's easy to install, and so we'll use it for a lot of water retention and containment applications. So lining ponds, lining environmental containment facilities, to keep dirty water from polluting the groundwater, to keep valuable water resources stored for future use. So this is where Rhino Mat starts. This is our compounder. And what we'll begin with is a plastic resin pellet where we're mixing these resin pellets with different additives, and we'll melt it down into what we call a master batch, which will become our polyethylene raw material to go to the tape line and start our manufacturing process for Rhino Mat. So once this master batch is good and mixed, we're bringing it over to the tape line, where we'll actually feed it into this hopper, and it will be melted down and extruded into a flat polyethylene film sheet. So here we have the master batch coming out of the hopper into the extruder. So when the master batch comes into this, it's actually a hot screw press, heating the master batch into 290 degrees Celsius. And it'll actually cast it through this extrusion die into a flat film. Once it comes through this die, it'll be quenched in a cooling bath and then rolled up to this area where we're actually slitting tapes. And those tapes will make up the reinforcing backbone of the Rhino Mat material.
Once the tapes are split, they're brought into a stretching oven that applies more heat, which in turn stretches the tape to the specified width.
Once it comes through the stretching oven and the tapes are at the requisite width, then we're bringing it into what we call an annealing station. So the annealing process is running it through these hot and cold rollers, and we're introducing some of the stretch and the strength properties of these tapes through this annealing process. So after the tapes come through the annealing line, they're being pulled into this winding bank, and you can see all these tapes being spooled into packages or bobbins where we're going to use them later in a weaving process. So once the tapes are spooled onto these bobbins, all bobbins are brought over to this enormous rack that we call a creel, and 532 tape ends are brought into this flat loom in the warp direction. It's pulled through, and a shuttle will shoot the tape across in the wet direction so that we can weave the reinforcement fabric on this enormous machine.
Once the weaving process is finished, the material is then transferred to this coating machine, where the reinforced fabric will be coated and turned into an impervious, waterproof material.
We're going to coat this reinforcement fabric in this machine, wind it through these winders, and come out the other side, and that's our Rhino Mat. This makes it impervious, waterproof material. Eventually, the Rhino Mat will have one more laminated film layer on the surface. We'll run it through the printer, put the logo on it, and this is an impervious geomembrane, great product for water retention and containment applications. In fabrication facilities, Rhino Mat can be welded together in panels as large as a half an acre. Here's some Rhino Mat that we're going to weld together. It's a very simple process. There's about a 3-inch overlap, a piece on top, a piece below. We're gonna seam this together in a continuous waterproof weld using this thermal fusion welder. Here's how it's done. That was hot. That was welded at 700 degrees Fahrenheit. These two pieces are fused together. This is a watertight seal, a very strong weld. It's almost impossible to pull apart. That's tough stuff.
It's still surprising that we are using high-density polyethylene geomembranes for potable water applications. There are a lot of applications and opportunities for fabricated materials to displace high-density polyethylene.
Whether it's installing an industrial containment pond, a drinking water reservoir, or a farming irrigation pond, Owens Corning's undeniable and unbeatable innovations continue to make our world a safer and better place.
That's the Rhino Mat story.